Hello, we're going to be talking about what programming paradigms are, generally speaking, before looking at procedural and object-oriented in a bit more detail. So the word paradigm is a really fancy sounding and quite vague word. This just means really approach. It's the approach to something. So a programming paradigm refers to a particular approach to how we program. There are a fair few paradigms which have come out in the last 50 years, and each have got their own pros and cons. It's often down to your personal preference which one you choose to use, or perhaps more realistically, often down to your boss's personal preference. But crucially, all of these different approaches can solve the same problem. They just do it in different ways. Most modern programming languages are multi-paradigm, which basically means they support multiple different approaches, like Python, which most of you study, supports a few paradigms, most notably procedural and object-oriented, which are the two on this course. There are some which mostly only support one paradigm. For example, a paradigm we won't talk too much about is functional programming, which is quite specialized, and a language called Haskell only really supports that. And a language like Java only really supports object-oriented. Most of us, whether we are aware or not, start learning programming under the procedural paradigm because it's kind of the simplest to get going a lot of the time. This is where a program is broken down into smaller subroutines. Despite it being called procedural, these subroutines can be functions or procedures. And I just mentioned functional programming, but that's a whole different thing. So here we are using these subroutines. Each subroutine should perform a specific task, and data gets passed around this program if we're doing things properly through parameters and also return values. And if we're not doing things properly, we might make our data global and allow it to be accessible through the whole program. If you are allowed to do that in procedural, you can make some data available everywhere. For most of you who've been programming for years, this is kind of your default approach to programming, I would say. But we also have object-oriented. So OO stands for object-oriented. You also see OOP, just short for object-oriented programming. In this approach, the data and the subroutines are really tied together, and they're packaged together into what are called objects. Whereas in the procedural approach, they're pretty independent, the subroutines and the data. We create these objects from classes. A class acts as a template, which defines the data and the subroutines an entity needs. And all of these words will be talked about later in this playlist. Quite importantly, object-oriented is designed to have relationships between these different objects. And the whole point of object-oriented is to try and model real life, to try and better represent the fact that in real life, objects connect with each other and interact. That's not really represented that well in the procedural approach. And the object-oriented paradigm supports three main techniques which don't exist in the same way in the procedural approach. We've got encapsulation, we've got inheritance, and we've got polymorphism. These boxes contain the kind of one-sentence summary. Again, we will come back to these concepts later in this playlist. If we were to look at a side-by-side comparison of these approaches being used to solve the same problem, which is just in this case calculating the perimeter and area of a rectangle, we can see lots of similarities, lots of differences. They are ultimately in the same language. This is in OCR pseudocode. We've got the same structure of our subroutines. We've got variables set in the same way. We've got the same kind of underlying operators like addition and multiplication. And this problem is too simple to need these, but we also still have selection, if statements, switch statements. We still have got the same loops in both of these approaches. They just go about solving the problem in a slightly different way. So procedural kind of keeps the data and the subroutines a bit separate, whereas in object-oriented, they're very much tied together. The data is kind of held within the same unit, the same class as your subroutines. Now, if we move on to evaluating these two paradigms, we can see a clear disadvantage of object-oriented just based on this side-by-side, which is that it's often a lot longer. So especially for quite simple projects, procedural does tend to be shorter, and we've got a lot less setup to get our code running. That can be one of the most off-putting things about object-oriented when you're first learning it, that you'll suddenly have to do a lot of work to get any code actually running. You've got to do the constructor, you've got to do the class definition, you've got to instantiate the objects. A lot more faff than procedural. And so this kind of has the consequence that procedural code is often a bit more concise than object-oriented. More concise code is good because it takes less time to write, it takes up less storage space, and it's easier to follow when you're trying to understand it. However, especially for complicated projects, which even at A-level you're not necessarily doing just yet, object-oriented tends to be a bit better. That's why I've given it a lot more space here. I think OCR definitely are biased towards object-oriented, so most questions are framed like, why is object-oriented better than procedural? So we kind of have to have more points ready to go for that. One of the key goals of the object-oriented approach is to try and better represent real life. In real life, we've got these entities, these different objects, and they are related to each other. Object-oriented does try and represent this, whereas procedural doesn't really attempt to do that. If you think about big projects where you've got multiple team members, you can independently work on different classes without affecting each other, allowing you to split up the workload across different people. And then we've got the benefits based on those 3 techniques I mentioned. First of all, encapsulation. Encapsulation makes code a bit more secure because the access to data can be a lot more easily restricted. Because the data can exist inside an object, it means you can lock down access and prevent anything outside of that object accessing it. Inheritance allows us to efficiently reuse code because I can take a class which is already defined and just slightly extend it without having to completely copy its code. And polymorphism allows us to use code quite flexibly. I only have to write it once and it can behave a little bit differently depending on what exactly it's interacting with. The alternative would be to have to write lots of different versions of that, which I'd have to do if it was procedural. And those bottom 2 points in particular often mean that in a big, complex project, actually it's object-oriented that's more concise than procedural. Although for smaller projects, for sure, procedural is a bit shorter.